Hello everyone, welcome to a new session on lipids. Lipids are a heterogeneous group of organic compounds which are widely distributed in living system, that is plants and animals. These are very important biomolecules in plants and animals. One of the important characteristics of lipids are insoluble in water and soluble in organic solvents. So once again, welcome to a session on lipids. We are going to discuss the lipids properties, function, and different types of lipids in detail. So lipids are organic compounds that are biomolecules which contains hydrogen, carbon, oxygen atoms, which forms the framework for the structure and function of living organisms. Lipids are seen in both plants and animals. In humans, lipids are synthesized in our liver. The lipids are mainly found in oil, butter, milk, cheese, and fried food items, etc. And this is the structure of lipid. As already said, lipid is insoluble in water. Lipids are actually polymers of fatty acids. It is the esters of fatty acids. Fatty acids are long chain carboxylic acid. So all the lipid contains a carboxylate and a non-polar hydrocarbon chain. From the structure it is clear. This is the polar head and this is the non-polar hydrocarbon chain. This is the structure of lipid. Chemically, lipid is a ester of fatty acid. So lipid is the combination of fatty acid and alcohol. That means all the lipids on hydrolysis gives fatty acid and alcohol. Then these are the properties of lipid. Lipids are oily or greasy type of material. In humans or animals, it is stored in the adipose tissue. These are made up of hydrocarbon, mainly long chain fatty acids. The biological importance of lipids are the main energy source of living system. This can provide 2 times energy than carbohydrate and protein. So the main energy storage is done in the form of lipid. Already we discussed the solubility. It is insoluble in water and it's soluble in non-polar solvents. Then this acts as the cushion for many internal organs in animals. These are the important properties of lipid. Then moving to the classification of lipids. Lipids are mainly classified into two categories, that is non-saponifiable lipid and saponifiable lipid. That is non-saponifiable lipid cannot be hydrolyzed into smaller molecule. So lipids that cannot be disintegrated into smaller molecule via hydrolysis is termed as non-saponifiable. We cannot break the molecule into smaller molecule using hydrolysis. For example, we cannot break cholesterol molecule. Cholesterol is a lipid molecule by hydrolysis into smaller components. That is called non-saponifiable lipid. Then the second type is saponifiable lipid. Saponifiable lipid means we can disintegrate or we can make smaller molecule from that lipid by hydrolysis. All the lipids on hydrolysis yield fatty acids and alcohol. This type of lipids are termed as saponifiable lipids. Example, wax, oil, fat, all are saponifiable lipids. Then another category of lipids are mainly of three type. This classification is also based on the hydrolysis. Already we discussed all the lipids on hydrolysis yields fatty acids and alcohol because all the lipids are esters of fatty acids, esters of long chain fatty acids. Based on the hydrolysis product, lipids are classified into two categories: simple lipids and compound lipids. Simple lipids are lipids which on hydrolysis gives two fragments, that is fatty acids and alcohol. This type of lipids are called simple lipids. A classical example for simple lipids are oils and fat and waxes. Oils and fats are esters of long chain fatty acids with glycerol. The main difference between oil and fat is oil is liquid at room temperature and fat is solid at room temperature. Another difference is oil contains mainly unsaturated fatty acid, or we can say oil is esters of unsaturated fatty acid with alcohol, but fat contains more saturated fatty acids. That is, fats are esters of saturated fatty acid. These are the difference between oil and fat. The biological importance of oil and fat are the main energy source of the body. We already discussed fat can produce two times energy than carbohydrate and protein. So body is always preferred to reserve the excess energy in the form of fat. Also, fat is a bad conductor of heat, so it acts as a thermal insulator for the body. It's seen below the skin layer. Then another importance is internal organs are protected by a coating or covering of fat. Another type of simple lipid is waxes. Wax are the ester of fatty acids with high molecular weight monohydric alcohol that are wax. Wax is on hydrolysis give this fatty acid and alcohol. The major uses of simple lipid, that means these fat and waxes are, these are the main energy source, or these are important role in nutrition. Then another importance is oils and fat are used for cooking, soap making, candle manufacture, glycerol manufacture, used as a lubricant. Then also these simple lipids are used in paint industry, varnish industry, leather industry, and also the production of synthetic detergents. These are the different uses of simple lipids. So simple lipids are esters of fatty acid with alcohol, or simple lipids on hydrolysis gives fatty acids and alcohol. Moving to the next category, that is complex lipid. Complex lipids are lipids which on hydrolysis forms fatty acid, alcohol and other compound. That means these type of lipids are formed by the combination of fatty acid, alcohol and other compound. For example, phospholipid. Phospholipid is a complex lipid, or we can say it is a compound lipid that contains three components. The normal components are fatty acid and alcohol. In addition to these normal components, there will be an additional component in phospholipid. The third component is phosphate group. That is why it is termed as phospholipid. That is, phospholipid on hydrolysis yield fatty acid, alcohol, and a phosphate group. Or we can say it is a phosphoric acid residue. Then another example is glycolipid. Glycolipid is also a complex lipid which on hydrolysis gives fatty acid, alcohol, and a carbohydrate group. That is why it is termed as glycolipid. Here it is a glycerophospholipid that also contains an additional group, the glycolipid, that contains fatty acid, sphingosine, and carbohydrate, that is fatty acid, alcohol, and carbohydrate. Then there is another type of lipids, that is derived lipid. In addition to simple and compound lipid, there is another class of lipid called derived lipid. Derived lipids are lipids that are actually derived from naturally occurring esterified material. Example for this compound is sterol like cholesterol. Cholesterol is a lipid, but it does not containing an ester linkage. Derived lipids are lipids which do not have a ester linkage. In first two cases, that is in simple lipid and compound lipid, there is an ester linkage. But in the case of derived lipid, there is no ester linkage, but it shows all the properties of lipid. So this is categorized into a third category called derived lipid. These lipids do not contain an ester linkage. We can say these are derived from naturally occurring esterified materials. Example, cholesterol. Then we are moving to the next topic, fatty acid. Fatty acids are the main component of lipids. Fatty acids are long chain carboxylic acid. We already discussed structure of this fatty acid. It contains two ends. That is, a long hydrocarbon chain is the major portion of this fatty acid, long chain fatty acid. There are two types of fatty acid, that is saturated fatty acid and unsaturated fatty acid. Saturated fatty acid means these are fatty acid which contains carbon-carbon single bonds. That means in this saturated fatty acid there is a lack of carbon-carbon double bond. These type of fatty acids have higher melting point compared to unsaturated fatty acids. Examples for this type of, that is saturated fatty acids, are lauric acid, palmitic acid, stearic acid. All these are belongs to the saturated type. Stearic acid is C17H35COOH, that is a saturated fatty acid. Then unsaturated fatty acid means fatty acid which contains a carbon-carbon double bond, at least one carbon-carbon double bond. These compounds are generally unbranched. This can exist in cis form and trans form. The examples for this type of fatty acids are oleic acid, linolenic acid, and also the essential omega-3 and omega-6 fatty acids are also belongs to this unsaturated fatty acid. This unsaturated fatty acid can exist as trans fat. This trans fat have a biological relevance.